Hello friends, now we will start the exercise 10.3 and in this video I will explain all examples from exercise 10.3 in a very simple language. Okay, now let us start. The first question, reduce the following equations into slope-intercept form and find their slopes and y-intercept. Okay, now the solution. Now the slope intercept form is y is equals to mx plus c. Okay, in this form, therefore the given equation x plus 7y is equals to 0 can be written as 7y is equals to minus x, and therefore y is equals to minus 1 upon 7x plus 0. If we compare this equation with y is equals to mx plus c, therefore slope, okay, slope is equals to m equal to minus 1 upon 7, and the y-intercept, okay, y-intercept is equals to 0, and this is the answer. This is the again form, y is equals to slope intercept form, y is equals to mx plus c. Now the next example, again the second equation is a 6x plus 3y minus 5 is equals to 0. Therefore 3y is equals to minus 6x plus 5. Divide on both sides by 3, and therefore here you will get y is equals to, if you divide this equation, here you will get y minus 6 upon 3x plus 5 upon 3, and therefore here y is equals to minus 2x plus 5 upon 3. This is in the slope intercept form. Next, therefore comparing with y is equals to mx plus c, therefore here slope is equals to minus 2, and y-intercept, okay, y-intercept is equals to 5 upon 3. Okay, and this will be answer. Okay, and in the form y is equals to mx plus c, this is the, okay, y is equals to mx plus c. Now the next example. Now the equation of the line is y is equals to 0. Now in the slope intercept form, y is equals to 0 x plus c. Again comparing with y is equals to mx plus c. Therefore here slope m is equals to 0, and y-intercept, okay, y-intercept that is also 0. Okay, here y-intercept is a 0, slope is 0, y-intercept is 0. As here the y is equals to 0, Okay, this is nothing but the equation of the x-axis, and x-axis has the slope 0 and its y-intercept is also 0. Okay, again the answer, the equation of the line, it is y is equals to mx plus c. Okay, I will take the next question. Question number 2. Reduce the following equations into intercept form and find their intercept on the axis. Okay. Now intercept form means what? It is x upon a plus y upon b is equals to 1. This is the double intercept. Therefore, we write here 3x plus 2y minus 12 equals to 0, and hence here 3x plus 2y is equals to 12. Divide on both sides by 12, and hence here you will get 3 upon x upon 12 plus 2y upon 12 is equals to 12 upon 12, and hence here you will get, that is a x upon 4 plus y upon 6, and that's equals to 1. Therefore x-intercept a is equals to 4, here is 4, and y-intercept b is equals to 6. Okay, and this is the answer. Now again I have the answer. Now the next problem. Now the next equation is a 4x minus 3y. 4x minus 3y is equals to 6. Again divide on both sides by 6. Therefore here you will get 4x upon 6 minus 3y upon 6 is equals to 6 upon 6. And after division you will get here 2x upon 3 minus 1 upon 2y is equals to 1. Again this can be written as x upon 3 by 2, okay, minus y upon 2 is equals to 1. This is in the standard form. Therefore, what are the intercept? The x-intercept is equals to 3 by 2, and y-intercept is equals to minus 2. Okay, this is the answer. Okay, and the again the in the intercept form. Okay. Now the next equation is 3y plus 2 equals to 0. Now again this can be written as 3y is equals to minus 2. Divide on both sides by minus 2, and then you will get minus 3 by 2y is equals to 1. That is y upon minus 2 upon 3 is equals to 1. This is line which is parallel to x-axis. Therefore, the x-intercept is equals to 0. And what about the y-intercept? Okay, y-intercept is equals to minus 2 upon 3. Okay, therefore this is the answer. These are the intercept. And next, in the form x upon a plus y upon b, this is the form. Now in the next question, reduce the following equation into normal form. Find their perpendicular distance from the origin and angle between perpendicular and the positive x-axis. Now the equation is x minus root 3 y plus 8 is equals to 0. Now the normal form is the x cos of alpha plus y sin alpha is equals to p. Now we'll write this equation in the standard form. That is, here is a minus x plus root 3y is equals to 8. We are keeping this 8 as a positive. Now dividing on both sides. Dividing on both sides by, okay, in root of minus 1 bracket square plus root 3 bracket square is equals to minus 1 square means what? 1 plus 3 is equals to 3 plus 1, that is 4, and equal to 2. Okay, therefore we'll divide here minus x upon 2 plus root 3 upon 2 y is equals to 8 upon 2. Okay, and then you will get here minus 1 upon 2x plus next is a root 3 upon 2 y, and that's equals to 4. Now we'll find out the angle. If we compare with the normal form, that is x cos of alpha plus y sin of alpha is equals to 4. It means that cos is negative and sin is positive. And for that, here we take, that is a alpha is equals to, okay, I will write here cos of alpha is equals to minus 1 upon 2 means what? Minus cos of here 60. Okay, cos 60. If we observe the negative sign, then here you will get cos of 180 minus 60 degree. Okay, and this cos of alpha is equals to cos of 120, and therefore the inclination, okay, the angle between the perpendicular and the positive x-axis, that angle between perpendicular and x-axis is 120, and the length of the perpendicular, that is a P is equals to 4. You can see this. Now the next problem. Now the next equation is y minus 2 is equals to 0. Again, this equation can be written as 0 x plus y is equals to 2. Dividing on both sides by, okay, dividing on both sides, okay, both sides by in root of, okay, in root of 0 square plus 1 square, and that is equals to 1. And therefore it can be written as 0 upon 1 x plus 1 upon 1 y, and that is equals to 2 upon 2, that is a 2. Now we'll compare this equation with, that is a x cos of alpha plus y sin alpha is equals to p. Now first of all angle, that is a cos of alpha is equals to 0 and sin of alpha is equals to 1. Therefore it's clear that alpha is equals to 90 degree. Okay, because cos 90 is a 0 and sin alpha, sin 90 is 1. But what about the value of p? That p is equals to 2. Therefore equation in normal form is x cos of 90 plus y sin of 90, and that's equals to 2. Okay, thus comparing with, okay, comparing with x cos of omega or alpha, okay, x cos of alpha plus y sin of alpha is equals to p. Here we have alpha is equals to 90 and p is equals to 2. Okay, thus finally we will write the answer. Thus the perpendicular distance of the line from the origin is origin is 2, okay, while the angle between the perpendicular and the positive x-axis positive x axis is 90. Okay, now you can see this. Okay, now next problem. Reduce the following equation into normal form. Find the perpendicular distance from the origin and angle between perpendicular and the positive x-axis. Now the given equation. Okay, given equation. Okay. X minus y is equals to 4 can be written as 1 dot x plus minus 1 into y is equals to 4. Okay. Now on dividing, both sides by in root of 1 square plus minus 1 bracket square is equals to in root of 1 plus 1, and that is equals to root 2. Okay, we obtain now we'll divide this equation by the root 2. Therefore, the equation is, see this here, 1 upon root 2 x plus minus 1 upon root 2 y is equals to 4 upon root 2. Okay, and then after simplification, here you will get 4 upon root 2 into root 2 upon root 2, that is a 4 root 2 upon 2, you will get 2 root 2. Okay, and therefore this can be written as 1 upon root 2 x plus in bracket minus 1 upon root 2, and that is equals to 2 root 2. Again comparing with x cos of alpha plus y sin of alpha is equals to p. Okay, and therefore here that is cos of alpha is equals to 1 upon root 2, and sin alpha is equals to minus 1 upon root 2. That is, cos is positive in fourth quadrant and sin is negative in fourth quadrant. Therefore, this can be written as sin of 2 pi minus pi by 4. Okay, and after simplification, here sin of alpha is equals to 1 upon root 2 and that is equals to here sine of 2 pi into 4, that is 8, and 8 minus pi, that is 7 pi by 4. Okay, and hence alpha is equals to 7 pi by 4. This is the alpha, and p is equals to 2 root 2. Okay, p is equals to 2 root 2. Thus finally we write the answer. Thus the perpendicular distance of the line from the origin p is equals to 2 root 2, while the angle between the perpendicular and the positive x axis is 7 pi by 4 or 350. Okay, now we take the next problem. Again, you can see this, how the problem is solved. Now the problem number 4. Find the distance of the point -1, 1 from the line 12 in bracket x plus 6 is equals to 5 in bracket y minus 2. The given equation of the line can be written as in the standard form. Okay, that is first we write the equation 12 in bracket x plus 6 is equals to 5 in bracket y minus 2. Now we'll simplify this. That is after simplification 12x, 12 into 6, 72, 5 into y, 5y, 5 into 2, 10. Okay, and therefore 12x minus 5y plus 72 plus 10, that is 82. Now comparing with ax plus by plus c is equals to 0, we get a is equals to 12, b is equals to minus 5, and c is equals to 82. Okay, now we apply here the distance formula. Okay, now the perpendicular distance of a line ax plus by ax plus by plus c is equals to 0. Okay, from a point x1 y1 y1, okay, and this distance d is equals to, in mod of this, x is replaced by x1, y is replaced by y1 plus c upon in root of a square plus b square. Okay, now substitute the values. Okay, what is a is a 12. Next, what is the point? The point we have given, it is a -1 1 -1 1. Okay, that is a 12 in bracket -1 plus b is -5 into 1 plus c is 82 upon in root of their coefficient square, means what, a square plus b square, in root of a square means what, 12 square plus 5 square. This mod is completed. Now the simplification, 12 into -1, this is the -12, next is -5 plus 82, and this whole divided by 12 square 144 plus 25 plus 25, and the next is -12 minus 5 will get -17 plus 82, and now their subtraction, this divided by 169. Okay, and their subtraction is a in mod of 82 minus 17, then here you will get 65, and root of 169 is 13. Okay, and overall here you will get 5 units. If you divide by 13 to the 65, you will get the 5. Therefore, required distance is equals to 5 units. Okay, therefore this is the answer. Okay, next problem, find the point on the x-axis whose distance from the line x upon 3 plus y upon 4 is equals to 1 or 4 unit. Okay, let point on x-axis is p x1 comma 0. Okay, now the distance of point from x upon 3 plus y upon 4 is equals to 1 is 4 units. Therefore, if we simplify this equation, then after the cross multiplication, you will get 4x plus 3y, 4 into 3, that is a 12, is equals to 1, and therefore 4x plus 3y is equals to 1 into 12, that is you will get here 12. Next, 4x plus 3y minus 12 is equals to 0. Okay. Now, by formula of perpendicular perpendicular distance of point from line AX plus BY plus C is equals to 0 is, which is the point? The point is x1 and y1. Therefore, here that this D is equals to in mod of A x1 plus B y1 plus C upon in root of A square plus B square. Okay. Now substitute the values. That is, the point is x1 0 and the perpendicular distance is 4 units. D is 4. Therefore, this D is 4. And what about the equation of the line? The line is 4x plus 3y minus 12 is equals to 0. Therefore, in mod of that is 4 into 4 into x1 plus 3 into the value of y is 0 and c is minus 12 upon in root of 4 square plus 3 square, okay, and that is equals to 4x1 plus 3 into 0 and minus 12 upon it's a square and root of 25 is a 5, okay, and therefore here we can write 4 is equals to 4x1 minus 12 upon 5. Okay, now again if we simplify, we will draw the modulus sign, then here plus or minus 4 is equals to 4x1 minus 12 upon 5, okay, and the next is a 4 into 5, that is you will get here 20. 4x1 minus 12 is equals to plus or minus 4 into 20. Here you will get plus or minus 20, that is equals to 4x1 minus 12. Okay, again the simplification. 4x1 minus 12 is equals to plus or minus 20. Now here we can take as a once as a positive and another as a negative. Therefore, 4x1 minus 12 is equals to 20, or 4x1 minus 12 is equals to minus 20, and hence 4x1 is equals to 20 plus 12, or 4x1 is equals to minus 20 plus 12. 20 plus 12, therefore here you will get 4x1 is equals to 32, or 4x1 is equals to minus 8, and hence x1 is equals to 32 upon 4, or x1 is equals to minus 8 upon 4, and therefore x1 is equals to 8, or x1 is equals to minus 2. Okay, and hence the required points are, hence the required point is 8, 0, okay, and minus 2, 0. Okay. Now you can see this. Find the distance between parallel lines. 15x plus 8y minus 34 is equals to 0, and 15x plus 8y plus 31 is equals to. Now it is known that the distance small d between parallel lines ax plus by plus c1 is equals to 0, and ax plus by plus c2 is equals to 0 is given by d is equals to mod of c1 minus c2 upon in root of a square plus b square. Okay, now substitute the values. Okay, we have for the first line c1 is minus 34, and for the second line c2 is 31. A and b are common for both of the line. A is 15, b is 8. Therefore d is equals to mod of minus 34 minus 31 upon in root of 15 square plus 8 square, and that's equals to minus here 65. Okay, 15 square is in root of 225 and 8 square is a 64. Okay, and this equals to minus 65 upon in root of 289. Okay, and this equals to, that is a minus 65 upon 17, and therefore this distance D is equals to, okay, 65 upon 17 units. Okay, this is the distance. Therefore the distance between that two parallel lines D is equals to 65 upon 70 units. Now the next problem, find the distance between parallel lines. Okay, the lines are L in bracket x plus y plus b is equals to 0 and L in bracket x plus y minus r is equals to 0. Okay, now the solution. The lines are L in bracket x plus y bracket complete plus b and L in bracket x plus y minus r is equals to 0. If we simplify, then you will get here Lx plus Ly here p is equals to 0 plus p is equals to 0 and Lx plus Ly minus r is equals to 0. Now comparing with, okay, comparing with ax plus by plus c1 and ax plus by plus c2 is equals to 0. Here a and b both are equal, therefore we write here a is equals to b is equals to L, and what about the p? That is a c1 is equals to p. Next, c1 is equals to p and c2 is equals to minus r. Therefore distance between parallel lines, okay, that's equals to in mod of c1 minus c2 upon in root of a square plus b square. Okay, now substitute the value. Okay, and this equals to c1 is p minus in bracket minus r upon in root of a is L and B is also L, therefore it is L square plus L square, and that is equals to mod of P plus R upon in root of 2 L square. If you take its a square root, then you will get 1 upon root 2 L and in bracket P plus R upon L. Okay, and therefore the distance between that two parallel lines is 1 upon root 2 P plus R upon L units. Okay, this is the distance. Therefore, finally, we write the answer. D is equals to 1 upon root 2 in bracket P plus R upon L units. Okay. See this answer. Now the next question. Find the equation of the line parallel to the line 3x minus 4y plus 2 is equals to 0, and that line passes through the point minus 2, 3. It means that the both of the line have the same slope. Okay, therefore we will find out the slope of this line. Now equation of line is 3x minus 4y plus 2 is equals to 0. Therefore we can write this equation in the form of y is equals to mx plus c. Therefore 3x minus 4y plus 2 is equals to 0. It can be written as 3x plus 2 is equals to 4y. Therefore 4y is equals to 3x plus 2. Now divide on both sides by 4, then you will get y is equals to 3 by 4x plus 2 by 4, and hence y is equals to 3 by 4x plus 1 upon 2. Okay, therefore the slope of a required line is 3 by 4, and it passes through the point what is the point? The point is minus 2, 3. Okay. Minus 2, 3. Now we know the slope as well as the point. Therefore, by slope point form, okay. Therefore, by the slope point form. What is that? Y minus y1 is equals to m in bracket x minus x1. Now substitute the values. Okay, y minus 3. The value of m is 3 by 4 in bracket x minus in bracket minus 2, and therefore y minus 3 is equals to 3 by 4 in bracket x plus 2. Therefore its simplification is 4 in bracket y minus 3 is equals to 3x, 3 into 2, it is a 6, 4y minus 12 is equals to 3x plus 6. Therefore this equation again can be written as minus 12 minus 6 is equals to 3x minus 4y. Okay, and again can be written as 3x minus 4y is equals to minus 18, and therefore 3x minus 4y plus 18 is equals to 0. Okay, this is required equation of the line. Okay, and now the next question. Again, you can see this. Question number 8. Find the equation of the line perpendicular to the line x minus 7y plus 5 is equals to 0, having intercept x-intercept 3. Okay, now we have the x-intercept. First of all, as the required line is perpendicular to x minus 7y plus 5 is equals to 0. Therefore, the slope of line x minus 7y plus 5 is equals to 0. Okay, now we'll find out the slope of the line x plus 5 is equals to 7y, and therefore y is equals to 1 upon 7 x plus 5 upon 7. Therefore slope of the given line is 1 upon 7, and slope of required line is the required line is minus and reciprocal of this, that is a minus 1 upon 7, and that is equals to minus 7. Therefore m is equals to minus 7. Also x-intercept what is x-intercept? Is 3. Therefore point on that line is 3 and 0. Okay, point on that line is a 3 and 0. Now we'll find out the equation of the line. Now equation of line having slope m is equals to minus 7 and point on that line is 3, 0. Means we know the point and it's a slope. Therefore its equation is a y minus y1 is equals to m in bracket x minus x1. Now substitute the values. M is minus 7, x1 is 3 and y1 is a 0. Therefore y minus 0. Next m is a minus 7 in bracket x minus 3. Therefore y is equals to minus 7x plus 21. Okay, and hence 7x plus y is equals to 21. This is required equation of the line. Okay, 7x plus y is equals to 21. It's a very easy question. We want to find out the slope of the line. Take its minus and reciprocal and pass the line from the point which is the 3, 0. Okay. First we find the slope. Take its minus and reciprocal. The slope is minus 7. X-intercept is 3. Therefore the point on line is a 3, 0. Now the equation of the line passing through, having the slope minus 7, passing through the line, passing through is the point, that is a 3, 0. We have the slope point form. Okay, this is the required equation. Now the next problem. Find the angle between the lines root 3x plus y is equals to 1. X plus root 3y is equals to 1. Now we'll find out the slope of the line. Okay, slope of line root 3x plus y is equals to 1. We can write in the form y is equals to mx plus c. Therefore this can be written as y is equals to minus root 3x Okay, plus 1, which is the form y is equals to mx plus c. Therefore, what is the slope? Slope m1 is equals to minus root 3. For the second line, for the second line, x plus root 3y is equals to 1. Therefore, that equation, again y is equals to mx, in the form y is equals to mx plus c, can be written as here root 3y, okay, minus x plus 1, divide on both sides by root 3. Therefore, here we will get minus 1 upon root 3 plus 1 upon root 3. Okay, again comparing with y is equals to mx plus c. Therefore, what about the slope? Therefore, the slope m2 is equals to minus 1 upon root 3. Now, angle between two lines, what is that angle between? The tan theta is equals to mod of m1 minus m2 upon 1 plus m1 into m2. Okay, and therefore here is a in mod of m1 is minus root 3, m1 is minus root 3, and again m2 is a minus 1 upon root 3. Okay, 1 plus m1 is minus root 3 and m2 is a minus 1 upon root 3, bracket complete. Okay, now simplify this. Here you will get minus, and this minus and minus, that will become plus 1 upon root 3. Again simplification, 1 plus this minus and minus, that will become plus root 3 into 1 upon root 3. So root 3 into 1 upon root 3, and next simplification, root 3 into root 3, minus 3 plus 1, this divided by root 3 upon this root 3 get cancelled, you will get 1 plus 1. Okay, and then minus 3 plus 1 will get minus 2 upon root 3. Okay, 1 plus 1, that is 2. The simplification, minus 2 upon root 3, and this is the 2 upon 1. It's multiplied and reciprocal, 1 upon 2. These 2 get cancelled, and you will get 1 upon root 3, and overall that is equals to 1 upon root 3. Okay, therefore tan theta is equals to 1 upon root 3. Okay, and that is nothing but tan of 30, and hence theta is equals to 30 degree. Thus the angle between two lines is 30 degree or 180 degree minus 30, which is equals to 150. Okay, therefore the answer is 30 degree or 150 degree. Okay, second easy question. Use the formula tan theta is equals to m1 minus m2 upon 1 plus m1 into m2. Substitute the value. You will get the acute angle is 30 degree and obtuse angle, which is 180 minus 30, that is 150. Okay. Now the question number 10. The line through the points H3 and 4,1 intersect the line 7x minus 9y minus 19 is equals to 0 at right angle. Find the value of h. Okay. Now see this here. Okay. Here. These are the two lines. Okay. And first line, this is the L1, whose equation is 7x minus, suppose that 7x minus 9y minus 19 is equals to 0. And suppose that this is the second line. The points on the line are, first is, I will write here, H3, and second point is a 4, 1. This is the line L2. As these two lines are perpendicular to each other, the product of slope of these two lines is minus 1. Okay. Now we'll find out the slope of first line. Okay. Now slope of line L1. Okay. What is its equation? 7x minus 9y minus 19 is equals to 0. Therefore, this equation can be written as 7x minus 19 is equals to 9y. Therefore, y is equals to, divide on both sides by 7. That is 7 by 9, x minus 19 by 9. Therefore, slope of line L1 is 7 upon 9. Now, we will find slope of line L2. Okay, and on line L2 these are the point H3 or 1. Okay, the first point is H3 and another point B is okay 4 1. Now the slope of L2 is equals to y2 minus y1 upon x2 minus x1. This is the point x1, y1, x2 and y2. Okay, y2 is 1 minus 3. Okay, x2 minus x1, 4 minus h. Okay, and this slope is equals to m2. Okay, now the product of the slope is minus 1. Here m1 is the slope of the line L1, m1. Therefore here m1 into m2 is equals to minus 1. What is m1? m1 is 7 upon 9 into m2 is 1 minus 3 upon 4 minus h is equals to minus 1, and therefore 7 in bracket 1 minus 3. 1 minus 3 is a minus 2 upon 9 in bracket 4 minus h, and that's equals to minus 1. Okay, after the simplification, here you will get minus 14 is equals to minus 9 in bracket 4 minus h. Therefore minus 14 is equals to minus 36, and this minus and minus, that will become plus 9h, and therefore 9h is equals to plus 36 minus 40, that is equals to here 22. Okay, therefore 9h is equals to 22, and hence h is equals to 22 upon 9. Okay, and this is the answer. Thus the value of h is 22 upon 9. Okay, and this is the answer. L1 equation is an 7x minus 9y minus 19. On L2 there are the 2 points h3 and 4 1. Product of, as the lines are perpendicular at right angle, the product of the slope is minus 1. You first find the slope of first line, then find the slope of the second line, take their product and simplify. Now we'll find out the slope of the line ax plus by plus c is equals to 0. Okay, therefore the equation can be written as by. Transfer this ax plus c to the right hand side. It will become minus ax minus c. Divide on both sides by b. Therefore y is equals to minus a upon bx minus c upon b. Now our required line is parallel to y is equals to minus a upon bx minus c upon b. Hence, its slope is minus a upon b, because these two lines are parallel. Okay. Now the equation of a line passing through x1 y1. Now equation of the line, okay, passing through x1 y1 having slope minus a upon b is y minus y1 is equals to n in bracket x minus x1. The lines are parallel, they have the same slopes. Therefore, the value of m is minus b upon a. Now substitute the value. Therefore, here you will get y minus y1. The value of m is minus a upon b in bracket x minus x1. Okay. Now the simplification. B in bracket y minus y1 is equals to minus a in bracket x minus x1, and again it can be written as a in bracket x minus x1 plus b in bracket y minus y1 is equals to 0. Hence, line through x1 y1 and parallel to ax plus by plus c equals to 0 is, what is that? A in bracket x minus x1 plus b in bracket y minus y1, and that's equals to 0. This is the answer. It's very simple question. Find the slope of the line and pass that line through this point. using the slope point form. Okay, you will get the answer. Now the next question, two lines passing through the points 2, 3 intersect each other at an angle of 60. If slope of one line is 2, find the equation of the other line. Now see these lines are, suppose that this is the first line and this is the second line. Okay. These two pass through the point 2. Okay, they intersect each other at the point 2, 3. Angle between them, the measure of this angle is 60. Suppose the line 1, its slope m1 is 2 and we want to find out the equation of the line L2. Also it's a slope. Okay, it is a question mark. Now we know that the tan theta is equals to m1 minus m2 upon 1 plus m1 into m2. Okay, this is the formula. Now substitute the value. The angle between them is a 60, that is a tan 60 is equals to slope of the first line m1 is 2 minus m2 upon 1 plus m1 is 2, therefore we have here 2 times m2 upon tan 60. Okay, then the value of tan 60 is root 3 and that's equals to mod of 2 minus m2 upon 1 plus 2m2. Okay, now we will evaluate this. Therefore this is equals to plus or minus root 3 is equals to 2 minus m2 upon 1 plus 2m2. Now we will evaluate this. Once we will take the plus sign and other minus sign. 2 minus m2 upon 1 plus 2m2 is equals to root 3 or 2 minus m2 upon 1 plus 2m2 is equals to minus root 3. Next simplification. 2 minus m2 is equals to root 3 in bracket 1 plus 2m2 or 2 minus m2 is equals to minus root 3 1 plus 2m2. Okay, and therefore 2 minus m2 root 3 into 1 you will get here root 3 Next 2 root 3 m2 or 2 minus m2 is equals to minus root 3, and next is a minus 2 root 3. This is the m2. Okay. Now the simplification. 2 minus root 3 is equals to 2 root 3 m2 plus m2, or next is a 2 plus root 3 is equals to m2 minus 2 root 3 m2. Okay. Now from here we take m2 as a common. Therefore 2 minus root 3 in bracket 2 root 3 plus 1 into m2, or again 2 plus root 3 in bracket 1 minus 2 root 3 into m2. Okay. Now we'll find out the, therefore here m2 is equals to 2 minus root 3 upon 2 root 3 plus 1, or m2 is equals to 2 plus root 3 upon 1 minus 2 root 3. Okay, these are the slopes. If you want the similar expression, then we can write, take the minus sign common from the denominator. Therefore, you will get 2 plus root 3 upon, in bracket, that is 2 root 3 minus 1. This is the slope m2. Now, equation of line when m2 is equals to, okay, 2 minus root 3 upon 2 root 3 plus 1. Okay. The given line passes through the point 2, 3. The line L2 passes through the point 2, 3. Okay. Here the point is 2, 3. The slope is m2 2 minus root 3 upon root 3 plus 1. Therefore, the equation of the line in slope point form slope point form, that is y minus y1 is equals to m2 in bracket x minus x1. Now substitute the values. Y minus 3, m2 is a 2 minus root 3 upon 2 root 3 plus 1 and in bracket x minus 2. Now the simplification. Y minus 3 into in bracket 2 plus the root 3 plus 1. 2 root 3 plus 1 multiplied with y minus 3, and that's equals to in bracket 2 minus root 3 into in bracket x minus 2. Now the simplification. Y into this whole bracket, that is 2 root 3 plus 1 into y minus 3 in bracket 2 root 3 plus 1, and this equals to again 2 minus root 3 bracket complete into x minus 2 in bracket 2 minus root 3. Therefore, if we shift this term to the right hand side, it will become minus 2 minus root 3x plus y. First we write here plus 2 root 3 plus 1 into y. Now transfer this constant to the right hand side, that is minus, that will become plus 2 root 3 plus 1 minus 2 in bracket 2 minus root 3. We take the negative sign as a common, then this will become positive, and therefore it can be written as root 3 minus 2x plus 2 root 3 plus 1 into y. And next simplification, 3 into 2 root 3. Therefore here you will get 6 root 3, 3 into 1, here 3, 2 into minus 2 into 2, minus 4. This minus and minus, that will become plus 2 root 3. And therefore root 3 minus 2 into x plus 2 root 3 plus 1 into y. Now the next simplification, what is that? 6 root 3 plus 2 root 3, that will become 8 root 3. 3 minus 4, it's a minus 1 plus here 8 root 3. Okay, now this is the first equation. Here, root 3 minus 2 into x plus 2 root 3 plus 1 into y, and that's equals to minus 1 plus 8 root 3. Okay, this is the first equation of the line L2. Now when the slope is minus 2 plus root 3 upon 2 root 3 minus 1. Now the equation of line with the slope m2 is equals to minus 2 plus root 3 upon 2 root 3 minus 1, and the point is 2, 3. That's y minus y1 is equals to m2 in bracket x minus x2. Now substitute the values. Y minus y1, that is a minus 3, is equals to minus 2 plus root 3 upon 2 root 3 minus 1 in bracket x minus 2. Next simplification, y into this whole bracket, which is the 2 root 3 minus 1 into y. Okay, again minus 3 in bracket 2 root 3 minus 1. Okay, and that's equals to x into minus 2 plus root 3 into x. Next, this minus and minus, that will become plus, that is 2 in bracket 2 plus root 3. Next simplification, take this term to the left hand side, it will become plus. Therefore 2 plus root 3 x plus 2 root 3 minus 1 into y, and transfer this term to the right hand side. Then here you will get 2 plus root 3. Again this minus, that will become plus 3 in bracket 2 root 3 minus 1. Okay, again this simplification, 2 into 2 4 plus 2 root 3. Okay, 3 into 2 6 root 3 minus 3. Okay, and therefore here we write 2 plus root 3x plus 2 root 3 minus 1 into y, and hence the answer 2 plus root 3 into x plus 2 root 3 minus 1 into y is equals to this 4 minus 3, that's 1, 2 plus 6 8, root 3. Okay, and therefore the answer is 2 plus root 3x plus 2 root 3 minus 1 into y, and that's equals to 1 plus 8 root 3. 2 plus root 3x plus 2 root 3 minus 1 into y is equals to 1 plus 8 root 3. Second one. And in this way, this is a big question. You can see this. Take plus or minus. Once you take plus and another is a minus 1. Next when m2 is 2 minus root 3 upon 2 root 3 plus 1. Then simplify. You will get the first equation of the line L2. Next, if we take m2 is equals to minus 2 plus root 3 upon 2 root 3 minus 1, and the point is 2, 3, then simplify this. Okay, you will get the answer. Find the equation of the right bisector of the line segment joining point 3, 4 and minus 1, 2. First, see this the figure here. This is the segment whose coordinate is a 3, 4 and B coordinate is a minus 1 and 2. The required line is a perpendicular bisector. Okay, and therefore here we have the line. You can draw it like this. This is the perpendicular bisector. This is the midpoint, and we want to find out the equation of this line L. The midpoint is M. Find the slope of AB. First we find out the slope of AB. Therefore, slope of AB is equals to, okay, difference of y coordinate, that is y2 minus y1 upon x2 minus x1. Okay, what is the y2? y2 is 2 minus 4 upon minus 1 minus 3, and that is minus 2 upon minus 4. Therefore, slope of AB is equals to 2 minus 2 by 4 means what? There is a 1 upon 2. Okay. Again, therefore slope of line L is equals to minus 1 upon slope of AB. Slope of AB. Okay. And this equals to minus 1 upon slope of AB. It's 1 upon 2. Okay. And that is equals to minus 2. Therefore, slope of line L is equals to minus 2. Now the required line passes through the midpoint of the segment AB. Therefore, we find out the coordinate of M. Okay, this is x1, y1 and x2 and the y2. Therefore, as M is midpoint of segment AB, therefore M is equals to, in bracket, sum of the x coordinate, that is x1 plus x2 upon 2, x1 plus x2 upon 2, and next y1 plus y2 upon 2. Okay, and this gives x1 plus x2, 3 minus 1 upon 2, and y1 plus y2, 4 plus 2, 4 plus 2 upon 2. Okay, and this equals to 3 minus 1, that is a 2, 2 upon 2, you will get 1. 4 plus 2, 6, 6 upon 2, you will get here 3. Therefore, slope of line L is minus 2, and it passes through the point 1, 3. Okay, therefore equation of line capital L is y minus y1 is equals to m in bracket x minus x1. Okay, now substitute the value y minus y1, y minus 3. The value of m is minus 2 in bracket x minus 1, and their simplification, y minus 3 minus 2x minus again plus. Therefore, the equation can be written as 2x plus y is equals to this. Transfer this minus 3 to the right hand side, it will become plus 2 plus 3, you will get 5. Hence, required line is 2x plus y equal to 5. Okay. Now the next question is, find the coordinates of the foot of perpendicular from the point minus 1, 3 to the line 3x minus 4y minus 16 is equals to 0. Now see this here, we have the line like this. Okay. Now the segment, it is perpendicular to this. It is a foot of perpendicular. It makes an angle of 90 degree. Here P is a point whose coordinate is a -1, 3, and M is the foot of the perpendicular. Okay, we want to find out this coordinate of M. The equation of this line L is, okay, it is a 3x minus 4y minus 16 is equals to 0. Now we will find out the equation of PM and solve these two equations simultaneously. Equation of this line, given line, it is L1, 3x minus 4y minus 16. We will find out the equation of the first PM. Now as the PM is perpendicular to L1, therefore its slope is minus and reciprocal of the slope of L1. Okay, and we know the point on the PM. We will apply the slope point form and we will get the equation of the PM, which is L2. Okay, this line will be L2, and solve simultaneously. You will get the coordinate of the foot of perpendicular. Okay, now first the slope of line L1. Slope of line L1. Okay, what is its equation? Its equation is a 3x minus 4y minus 16, and that's equals to 0. Therefore we can write it 3x minus 16 is equals to 4y. Divide on both sides by 4. Therefore y is equals to 3 by 4 x minus 16 by 4. Okay, and therefore it's a 3 by 4x minus 4. Therefore slope of L1 is 3 by 4. L2 is perpendicular to L1, therefore slope of L2, therefore slope of L2 is equals to minus 1 upon slope of L1. Okay, and the slope of L2 minus slope of L1, it is a 3 upon 4, and that is equals to minus 4 by 3. Therefore slope of L2 is equals to minus 4 by 3. Therefore equation of L2, whose slope is minus 4 by 3 and point on it is, which is the point? The point is minus 1, 3. Okay, the point is minus 1 and 3. Therefore y minus y1 is equals to m times in bracket x minus x1, and it is a y minus 3 is equals to, what is the slope? it is minus 4 by 3 in bracket x minus in bracket minus 1, and therefore y minus 3 is equals to minus 4 upon 3 in bracket x plus 1. Therefore, after simplification, 3 in bracket y minus 3 is equals to minus 4 in bracket x plus 1. Okay, and therefore 3y minus 9 is equals to minus 4x minus 4, and therefore 4x plus 3y is equals to minus 4 plus 9, and that's equals to 5. Therefore 4x plus 3y is equals to 5. Okay, this is equation 2. And what about the equation 1? This we will treat as the equation 1, which is the 3x minus 4y is equals to 16. Okay, this is equation 1. Now we'll solve these two equations simultaneously. Equation 1 is a 3x minus 4y is equals to 16. Okay, once again we'll check that equation. 3x minus 4y is equals to 16. Solve this simultaneously. Okay, to solve this equation simultaneously, multiply the equation 2 by 4 and 1 by 3. Then what you will get, and then add these two equations. It is 4 into 4x, you will get 16x plus 12y is equals to 20. Then multiplied with 3, it is a 9x minus 12y and 48. Okay, if we add these two equations, then plus 12 minus 12 will get cancelled. 16x plus 9x, you will get 25x, and here 58, 68. 68. Therefore, x is equals to 68 upon 25. Now put x is equals to 68 upon 25 in equation 4x plus 3y is equals to 5. Okay, substitute here. Therefore, 4 into 68 upon 25 plus 3y is equals to 5, and hence you will get 3y is equals to 5 minus 4 into 68 upon 25. Okay, and after simplification, that is equals to, this is 25 into 5, you will get 125 minus 272 upon 25. Now the subtraction, 125 minus 272, you will get minus 147, and therefore this y is equals to minus 147 upon 25 into 1 upon 3, and here you will get minus 49 upon 25. This is the y is equals to 25. Therefore, the required coordinates of the foot of the perpendicular are, okay, that is for the coordinates 68 upon 25, 68 upon 25, comma, minus 49 upon 25. Okay, it's an easy example. Only we want to find out the point of intersection of these two lines L1 and L2. This is the L1 and this is L2. We know the point on L2. The slope of P1 is nothing but the minus and reciprocal of the slope of line L1. Then we will get the two equations of the line and then solve it simultaneously. Okay. Now we'll take the next problem. Now the problem number 15. The perpendicular from the origin to the line y is equals to mx plus c meets it at the point minus 1, 2. Find the values of m and c. Okay. Now here the solution. Then what will the rough sketch of this problem? See this here. We have this is the x-axis, O is the origin, XO, X dash, and here the y-axis, YO, Y dash. Now the perpendicular drawn from the origin meet at the point minus 1 and 2. Okay. Now the next, the second line will be, it's like this. This is the line L whose equation is a y is equals to mx plus c. If we draw the perpendicular from origin to this line, it will meet here. Okay. Meet at this point. Okay. OM is the perpendicular whose coordinate is a m minus 1, 2. Okay. Now we'll find out the slope of this line, and OM, it's a minus and reciprocal of the slope of the line y is equals to mx plus c. Okay. And also the point minus 1, 2 lies on this line. It satisfies that equation of a line. First, we will find out the slope of OM. Now, slope of OM. Okay. Here is a difference of O has the coordinate 0 and 0. Okay. Therefore, 0 or 2 minus 0, difference of Y coordinate 2 minus 0 upon minus 1, 0. Here you will get minus 2. Therefore, slope of OM is equals to minus 2. Therefore, slope of line L is equals to minus 1 upon slope of OM. Okay. And this equals to minus 1 upon slope of OM, which is the minus 2, and this minus and minus, that will become plus. Okay. Therefore, slope of line L is 1 upon 2. Now we know the slope of line L and also point on the line L. Now we know slope of line L, that is M is equals to 1 upon 2, and point on it is point is minus 1, 2. Okay. And therefore, the Y is equals to mx plus c. Therefore, Y is equals to, substitute the value of m, which is 1 upon 2 x plus c. Now this point minus 1, 2 lies on this line. It satisfies the equation of the line. The point minus 1, 2 lie on above line. Therefore, we substitute y is equals to 2, 1 upon 2, x is minus 1 plus c. Okay. And therefore, 2 is equals to minus 1 upon 2 plus c, and hence c is equals to 2 plus 1 upon 2, 2 into 2, 4, 4 plus 1 is a 5 upon 2. Therefore, c is equals to 5 upon 2. Therefore, m is equals to 1 upon 2 and c is equals to 5 upon 2. Okay. This is the answer. Now see this here. This is the line L whose equation is y is equals to mx plus c. Okay. The perpendicular from the origin to the line meet at the point -1, 2. From the origin we draw the perpendicular OM and the point is -1, 2. That's why we find out the slope of OM. The slope of line L is nothing but the minus and reciprocal of the slope of OM. Therefore, we get the slope of line L, which is 1 upon 2. Now we know the slope and also point on the line L is a -1, 2 and its slope is 1 upon 2. Substitute the values, you will get the value of C is 5 by 2 and hence answer M is equals to 1 upon 2 and C is equals to 5 by 2. If P and Q are the length of perpendiculars from the origin to the lines x cos theta minus y sin theta is equals to k cos of 2 times theta and x sec theta plus y cosec theta is equals to k respectively. Then prove that p square plus 4q square is equals to k square. Now the formula, the perpendicular distance of point x1 y1 to the line ax plus by plus c is equals to 0 is, okay, what is that? D is equals to in mod of a x1 plus b y1 plus c upon in root of a square plus b square. Okay. Now we will apply this formula for the first line. If P is length of perpendicular from origin that is x1 y1 is 0 0 on the line, okay, on line, what is that? X cos theta minus y sin theta minus y sin theta is equals to k cos of 2 theta. Okay. Then what is the distance? This distance P is equals to, substitute the value of this x is 0, that is a 0 into cos theta, next minus 0 into sin theta, okay, and next minus k cos of 2 times theta upon in root of, okay, cos square theta plus sin square theta Okay, if you substitute, then here you will get P is equals to minus K cos of 2 times theta. Sin square theta plus cos square theta is 1, and overall you will get K cos of 2 times theta. Okay, therefore P is equals to K cos of 2 times theta, and this is the first one. Now the next, now Q is perpendicular from origin to the line. Okay, now which is the line? That is a x sec theta plus y cosec theta is equals to K. X sec theta plus y cosec theta is equals to K. Okay, therefore by the distance formula here we have this x is replaced by 0 into 0 into sec theta plus 0 into cosec theta minus K upon in root of sec square theta plus cosec square theta. Okay, and then simplify this. Therefore here you will get Q is equals to mod of minus K upon in root of sec square theta plus cosec square theta. Here this mod is completed. Again normally we will simplify this. That is K upon in root of, okay, K upon in root of sec square means what? 1 upon cos square theta. Cosec square means what? 1 upon sin square theta. And after simplification you will get here K upon in root of, okay, sin square theta plus cos square theta upon sin square theta into cos square theta. Okay, and this equals to K upon, what is the value of sin square theta plus cos square theta? It's a 1. Therefore 1 upon sin square theta into cos square theta. If we take it's a square root, then here you will get 1 upon sine theta into cos theta, and again if we simplify, then q is equals to k into sine theta into cos theta, and this is number 2. But what we want to prove that? We want to prove that p square plus 4q square is equals to k square. Therefore this is the one and this is the second. Therefore from 1 and 2, what is that? P square plus 4q square is equals to, what is the p square here? P square is a k cos of 2 times theta, k cos of 2 times theta, it's a bracket square, plus 4q square means what? 4 into k sine theta into cos theta whole square. Okay, that is, you will get k square cos square 2 times theta plus, now the square of this, k square sine square theta into cos square theta, that is k square cos square 2 times theta plus, here is a k square, now 4 sine square theta into cos square theta. Okay, and this can be again written as k square cos square 2 times theta cos square 2 times theta plus again k square in bracket 2 sine theta into cos theta, it's a whole square, and that's equals to k square into cos square 2 times theta plus k square. Okay, 2 sine theta into cos theta, this is nothing but sine of 2 times theta, it's a bracket square. Okay, now we will take the k square as a common, then in bracket you will get cos square 2 times theta plus sine square 2 times theta, but the cos square 2 times theta plus sine square 2 times theta, that is equals to 1. Okay, is equals to k square, and hence this is equal to p square plus 4, hence p square plus 4 q square is equals to k square, hence it is a proved. Okay. Now you can see this again. It's very simple. P and Q are the length of perpendicular from the origin to the line. Then prove that P square plus 4Q square is equals to K square. This is the distance formula. Apply this distance formula from the origin to this line. You will get P. Okay. This is equation 1. Next, Q is a perpendicular from origin to this line. You will get here after simplification. This simplification is very important. Okay. Q is equals to K sin theta into cos theta, and then substitute the values. What is that? You want to prove that P square plus 4Q square is equals to K square, and substitute the values of P and Q and simplify it. Then you will get the required proof. That is the P square plus 4Q square is equals to K square. Now we'll see the next example. Now the next problem, in triangle ABC with vertices A 2 3, B 4 minus 1, C 1 2. Find the equation and the length of altitude from the vertex A. Okay. Now see this here figure. Okay. This is the triangle ABC. A is 2 3, B whose coordinate is 4 minus 1, and here C. Now the altitude from the vertex A, this is the altitude, AM is the altitude, okay. Now the equation of altitude, we will find out the equation of altitude. Equation of altitude. Okay. The first we'll find out the slope of BC, and minus and reciprocal, that will be the slope of this altitude AM. Okay. This is the altitude AM. We know the point on this altitude, which is A 2 3. Now the slope of BC, and that's equals to difference of y coordinates 2 minus in bracket minus 1 upon difference of x coordinate, that is a 1 minus 4, that is 2 plus 1, and here is a minus 3 upon minus 3, and that's equals to minus 1. Therefore slope of BC is equals to minus 1. Therefore slope of AM is equals to minus 1 upon slope of AM. Okay, sorry, slope of BC. Here slope of BC, and that is equals to minus 1 upon minus 1, which is 1. Therefore the slope of AM is equals to, therefore slope of AM is 1, and point on it is which is A. What is that point? The point is 2, 3. Therefore, equation of AM, okay, by slope point form. Here we know the slope of AM is 1 and point is 2, 3. And therefore, here we apply the slope point form, which is y minus y1 is equals to m in bracket x minus x1. Okay. And therefore, the y minus 3 slope is 1, x minus 2. Simplify this. Y minus 3 is equals to x minus 2. Therefore, the equation is x minus y is equals to minus 3 plus 2 after simplification. Then here you will get x minus y is equals to minus y. Therefore, equation of altitude AM is x minus y plus 1 is equals to 0. Now we'll find out the length of this altitude AM. For that, here we will require the equation of BC. Okay. Now we'll find out the slope of BC, that is minus 1. We will find out the equation of BC. Here the slope of BC, slope of BC. What is that slope? Slope of BC is minus 1. Okay. Slope of BC is minus 1. Therefore, equation of BC. What is the point? C is a point on BC and whose coordinate is a 1, 2. Slope is minus 1. Therefore, by slope point form, okay, what is that? Y minus y1 is equals to m in bracket x minus x1. Substitute the value. Y minus 2 is equals to minus 1 in bracket x minus 1, and therefore y minus 2 is equals to minus x plus 1, and hence x plus y is equals to, what is that? Or we will write here x plus y minus 2 minus 1, that will become minus 3. This is equation of BC. Okay. Now perpendicular perpendicular distance from A on BC. Okay. What is the point A? The point A is 2, 3. Okay. Point A is 2, 3. And equation of BC. Equation of BC is x plus y minus 3 is equals to 0. What is that formula? The length of altitude. This is the A x1 plus by1 plus c upon in root of a square plus b square. Therefore, this d is equals to. What is the equation? The first is the 2 into 1 plus b, that is its coordinate is again 1 into 3 minus 3 upon their coefficient square, that is in root of 1 square plus 1 square, and therefore here you will get, and that's equals to 2 into 1, it is 2 plus 3 minus 3 upon in root of 1 square plus 1 square, that is 1 plus 1 plus 3 minus 3 get cancelled. You will get 2 upon root 2, and that is nothing but the root 2. Therefore, d is equals to root 2 unit. Therefore, equation of altitude is x minus y plus 1 is equals to 0, and the length of altitude is root 2 units. Okay. Now again you can see this. First we find the equation of the altitude, but before that the altitude is perpendicular to BC, and that's why we find out the slope of BC. It is minus 1, and then slope of AM is minus and reciprocal of minus 1. Therefore, the slope of AM is 1. Slope of AM is 1. Now the slope of AM is 1, and the point on it is 2, 3. Therefore, the equation of the AM by the slope point form, you will get the x minus y minus is equals to minus 1, or the altitude equation of the altitude is x minus y plus 1 is equals to 0. Now then we find the equation of BC. Slope of BC is minus 1, and the point we take here 1, 2. Again by the slope point form, we get the equation of BC. X plus y minus 3 is equals to 0. Now the perpendicular distance from A on BC. Okay, A is 2, 3, and equation of BC is x plus y minus 3. Therefore, here the distance d is equals to root 2 units, and hence the answer. Now next, problem number 18, and this is the last problem. If P is the length of perpendicular from the origin to the line whose intercept on axis are A and B, then show that 1 upon P square is equals to 1 upon A square plus 1 upon B square. Okay. Now here the coordinate axis. See this here. Okay. X axis xo x dash. Next yo y dash. Okay, and there is a line. This is the line whose equation is x upon a plus y upon b is equals to 1. Okay, now the perpendicular from this origin is p. P is the length of the perpendicular, pm is the perpendicular, o is the origin. Now equation of line whose intercepts on axis is whose intercept on axis are A and B is x upon a plus y upon b is equals to 1. Okay, now here we will simplify this. B into x plus a into y upon ab is equals to 1, and therefore bx plus ay is equals to ab, and therefore bx plus ay minus ab is equals to 0. Now length of perpendicular distance from origin on line bx plus ay minus ab is equals to 0 is p, and therefore by formula this this distance is equals to p is equals to x is replaced by 0 plus a into 0 minus ab upon in root of b square plus a square, and therefore p is equals to minus ab upon in root of a square plus b square, and hence we have p is equals to ab upon in root of a square plus b square. Now squaring on both sides, then you will get p square is equals to a square b square upon a square plus b square, and then simplification. What is that? A square plus b square upon a square into b square, and that is equals to 1 upon b square. If we simplify this a square upon a square into b square plus b square upon a square into b square, and that is equals to 1 upon p square. Therefore, it is 1 upon b square plus 1 upon a square is equals to 1 upon p square. Again, it can be written as 1 upon a square plus 1 upon p square. 1 upon b square is equals to 1 upon p square, and hence it is proof. Okay, 1 upon, and finally we write here, therefore 1 upon p square is equals to 1 upon a square plus 1 upon b square. We want to prove. Okay, simple problem. Perpendicular distance from origin on the line whose intercept on the coordinate axis are a and b. That equation is nothing but the x upon a plus y upon b is equals to 1. If we simplify, then you will get the equation of the line bx plus ay minus ab is equals to 0. Now the perpendicular distance from origin on the line bx plus ay minus ab is equals to 0 is, and if we simplify this, then you will get the required result. And in this way, I had completed the exercise 10.3. Now we'll see in the next video. Till then, goodbye.